analyze finite element models. This series is aimed at raising awareness of finite element theory and its practice. A number of exercises are presented in this series, some of which are taken from NEFM Workbook of Examples R0019. In every exercise, we are going to present to you a description of the problem, the theory involved, the theoretical solution, and how to use patran and nastran to obtain the desired results, and compare them with a theoretical solution. When you have completed the series, you should be able to acknowledge the benefit of using finite element analysis when designing structural, mechanical, and dynamic systems, and be able to use patran and nastran in your own applications. There are 9 exercises presented in this series. You should start with the introduction and follow the exercises in order. Workflow in patran. Before starting to work with patran, it is important to understand the workflow diagram. A typical workflow diagram is illustrated on this slide. First, we start off by building the geometry. Then we create an analysis model. Then we perform the analysis. Finally, we evaluate the results. If the results are acceptable, the job is complete. If the results are unacceptable, we modify the model and start again. As you go through the exercises, you'll notice the workflow cycle repeated over and over again. Let's take a tour. First, I'm going to show you how to open patran. Then, I'm going to teach you how to open a database, and talk to you a little bit about the working directory. I'll discuss a little bit about patran's graphical user interface, and talk to you about some of the important mouse clicks and how to change the background color. It is important to note that patran does not automatically convert units. This means the output in patran will be the same as your input. So, if your input length is in millimeters, the output length will also be in millimeters. If the force is in newtons, the output force will also be in newtons. In this case, stress will be reported as newtons per millimeter squared. You can open patran either by going through the Start menu or using the desktop icon. To go through the Start menu, click on Start, Programs, MSC Software, Patran 2010, and click on this icon. To open patran using the desktop icon, simply double-click on the icon. For the purpose of this demonstration, I'm going to open a database that's already been created. To open a database, either click on File and select Open, or simply click on the File Open icon. Notice as soon as I click on the File Open icon, it is directing me to the file I'm looking for. In the folder patran, patran is my working directory. To show this, I've opened my working directory, and this is the file I'm opening. Select the file and click OK to open the file. This is a bearing support that has been created, analyzed, and the results have been reviewed. Through most of the design cycle, I'm going to use the left mouse button, except to move, rotate, and zoom. To rotate the model, press and hold the middle mouse button, and move the mouse to rotate the object. This end of the model is fully constrained. That is, it has 0 x, y, and z displacements, and 0 rotation about all 3 axes. A uniform pressure load is applied on this curved surface. To move the model, hold Shift and the middle mouse button. You can move the model right or left, and up or down. To zoom, use the combination of Control and the middle mouse button. You can zoom in and zoom out, or you can use the zoom in, zoom out icons under the Home tab. As mentioned before, I'm going to use the left mouse button for majority of my tasks, including building a geometry, creating an analysis model, performing the analysis, and evaluating the results. Building a geometry and creating an analysis model is also known as pre-processing. Evaluating the results is also known as post-processing. Both pre-processing and post-processing is carried out by patran. Performing the analysis, or analyzing the model, is also known as processing, and this is carried out by nastran. And it is during this process that the output files are generated. These are the typical files that you will find in a working directory. To set or change your working directory, simply right-click on the icon you used to open Patran and select Properties. Under the shortcut tabs, the Start In field will tell you what your working directory is. Some of the important files in the working directory are the database file and the BDF file. The BDF file is the nastran input file. To show this, I'm going to open the BDF file. The working directory also consists of the .xdb file, the nastran output database file, which contains the results. The .fo6 file will contain all of the information about the geometry and the results. It will also contain any error messages if the analysis did not run properly. Another important file in the working directory is a patran session file. It is a log of all of the work that was done during a given session. The significance of the session file is that it could be played to generate the same model, and it will also generate the output files. If I play this session file as it is, it's going to ask me to replace all of my files, including the database file. To avoid that, I'm going to edit my session file by removing the first half and also removing the analysis part. Save the file and then close. Close this database and then create a new database. File name, bsupport. Under Model Preferences, set tolerances as default. Analysis code is MD nastran, and analysis type is structural. The viewport background at the moment is blue. To change the viewport color, click on Viewport, and click on Modify, and click on Background Effects. You can change the color to any color that you want. You can click on this icon to swap between two colors. In this case, it's going to swap between black and white. To play the session file, click on File, Session, and click on Play. I'm going to select this file. This is the file I've adjusted before, and click on Apply to play. Playing the session file is now complete. The next step is to perform the analysis. Click on the Analysis tab and analyze entire model, full run, job name, bsupport. Solution type is linear static, which is the default solution type, and click Apply to run the analysis. As soon as I click the Apply button, a series of files will be generated for bsupport. The job is now complete. To look at the results, first I'm going to attach the results file. Set action as access results, object as attach xdb. Select results file and select bsupport, which is the output database file, and click Apply to attach the output database file. The output database file should be attached manually because Patran won't know when the analysis code has completed a given job. It also gives the flexibility to the user to attach the results file whenever it's convenient. It also gives the option to attach sets of results to achieve the desired output. To look at the results, click on the Results tab and select Fringe and Deformation Results. Select Stress Tensor under Fringe Results and Constraint Forces under Deformation Results and click Apply. To clean up the view, click on Display and select Plot or Erase, and erase the geometry. The image is all cleaned up now. Let's look at the displacement results. Change both Fringe Result to Displacement Translational and Deformation Result to Displacement Translational. Click on Deform Attributes and change the True Scale factor to 5. Click Apply to display the deformation results. To animate the results, check Animate and then click Apply. Slow the animation down a little bit. Move and rotate the view to look at the effects on the areas of interest. To exit the animation, click on Refresh Results tool. To close Patran, we recommend that you use the File menu. Now it's time to start exploring. To find out more about Patran's user-friendly graphic user interface, powerful geometry import, export, and creation, robust meshing algorithms, fast results visualization and reporting, and extensive analysis code preferences. And finally, try using patran and nastran in your own applications. Follow the tutorials in this series starting from the first exercise. If you have any questions or problems, you can log into our academic discussion forums for Patran and Nastran, where you can seek help from a wide community of users.